Good afternoon, everyone. Welcome back and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, today we're talking about a topic that pertains to youth and and your memory. So, and some mice. So, here we go.
Some memories from adolescence may not disappear. The brain may simply lock them away for a time while its memory system is being rebuilt. A study in mice has uncovered an unexpected wave of remodeling in a brain region that helps preserve and retrieve long term memories. During late adolescence, the protective structures surrounding key neurons temporarily weakened, making experiences from earlier life harder to recall. These memories often return in adulthood, but some had lost their original precision. Would you like to know more?
The findings published in PLOS Biology, published in July 17th of this year by researchers at the Albert Einstein College of Medicine, offer a possible biological explanation for why access to older memories can shift as the brain matures. They also reinforce the idea that adolescence is not a brief transition that ends with the teenage years, but a prolonged period in which neural circuits continue to reorganize.
The researchers focused on the retrosplenial cortex, RSP, an area that helps connect experiences with places, context, and previously stored information. Man, again, I don't know. I'll take their word for it, but I don't know how they can parse the brain into these areas. And this is what this area does. This is what this area does. Way over my head, you know? Okay. Although it receives less public attention than the hippocampus, the RSP is an important part of the network the brain uses to retrieve established memories.
In late adolescent mice, the team found that pre-neuronal nets in the RSP declined sharply before recovering in adulthood. These mesh-like structures form around certain neurons and help stabilize the connections that preserve information over time. Their temporary loss may make memory circuits more flexible, but it also older memories may make older memories more difficult to access. So I don't know. I mean, I got a pretty good memory, I think, so far. You know, I'm sure there's a lot of people that probably hope that my memory fades, but yeah, I can remember stuff that happened when I was a kid, and I mean not everything, but key stuff.
It's fuzzy, right?
What's that?
It's fuzzy. Those memories are not sharp and yeah, I did this, yeah, I said this, you know?
Yeah.
They're vague.
Right. And then, you know, you also think about when they're older, they'll go see a psychiatrist or a psychologist or whatever. I don't know who they're going to go see. And these people, all of a sudden, they start asking questions, and then stuff starts bubbling up or percolating up in their memory that, you know, bad stuff that happened. I don't know, you never hear about good stuff, but you always hear about the bad stuff that happened. And then that causes issues. And, you know, again, I'm not saying that it's not accurate or true, but maybe, I don't know if this is on that same wavelength. I don't know. But it's kind of weird. So.
Okay, the same changes did not occur in the nearby hippocampus, which is strongly involved in forming and organizing new memories. That regional difference suggests that adolescence does not reshape every part of the memory system in the same way.
Okay, a quote here. We've known for years that the brain continues developing through adolescence and youth or in young adulthood. And that's according to senior author Jelena Radulovic, MD, PhD, professor in the Dominic P. Purpura Department of Neuroscience and of Psychiatry and Behavioral Sciences at Einstein. I probably butchered that last name there, but anyway. Our findings begin to explain what that developmental process looks like in one of the brain's memory circuits and how it can influence the way earlier experiences are recalled. So maybe that's kind of what I was just talking about. You know, maybe Maybe this stuff is stored. Maybe the bad stuff is stored in a certain part of your brain, and they're able to draw that out. I don't know.
Okay, this is a long quote. We're continuing here. We do not yet fully understand the consequences of the observed fluctuations of perineuronal nets, but we believe that their reorganization in RSP helps prioritize access to memories formed in adulthood at the expense of those formed in early adolescence. This could help to better adapt to the circumstances and challenges encountered during adult life stages. We are investigating whether preventing such fluctuations in adolescence could have any negative consequences in later life. End quote.
Earlier studies had suggested that the memory circuits examined by the team were largely mature by early adolescence. The new results challenge that view. Rather than remaining stable, an important part of the system appears to enter a temporary period of instability later in adolescence before settling again in adulthood.
That timing is especially relevant because the human brain also continues developing well beyond the teenage years. Processes involved in planning, impulse control, emotional regulation, and decision making can continue maturing into the mid to late 20s. According to the National Institutes of Health, the brain remains underdeveloped during this extended period.
To test the effects on memory, the researchers placed mice in a chamber where they received a mild foot shock. Okay. When
That's
returned
cool, man.
shortly afterward, the animals froze, showing that they remembered the unpleasant experience.
It's
Okay.
like putting a shock collar around your spouse. What'd you say? Click. The response changed with time. Many mice trained during early adolescence stopped freezing when they were returned to the chamber several weeks later. Adult mice trained in the same way continued to respond, indicating that their memories remained more stable.
The adolescent memories had not been erased. When the mice were reminded of the unpleasant event in a different setting, their fear of the original chamber returned. The experiment showed that the information was still stored, but had become temporarily difficult to retrieve.
The researchers linked this loss of access to reduced levels of proteins needed to build and maintain perineuronal nets. Activity of TGF beta 2, a growth factor that supports those structures, also fell during the same period.
When the team strengthened the nets or restored TGF beta 2 activity, the animals again became able to retrieve memories formed earlier in life. That result provided direct evidence that the structural changes were not merely associated with memory loss, but were helping cause the retrieval problem.
By mid-adulthood, many of the inaccessible memories returned without intervention. However, they were no longer as specific. Instead of reacting only to the chamber where the shock occurred, the mice also showed fear in unfamiliar environments.
Such generalization may reflect a trade-off. Remembering the broad emotional lesson of an experience can be useful even when its precise context has faded. A dangerous encounter, for example, may shape future behavior even if the details of where and when it happened become blurred.
The researchers compared this pattern with the reminiscence bump, the tendency for adults to recall an unusually large number of memories from adolescence and early adulthood. These memories often retain strong emotional meaning, even when their finer details are incomplete.
Whether the two phenomena are driven by the same biology remains unknown. The researchers say that the later return of adolescent memories can result from an age-related increase in perineuronal, how did you pronounce that?
Perineuronal
Nets. Repeated exposure to similar experiences, the replay of old events, or another process that has yet to be identified. Schizophrenia and major depression frequently emerge during late adolescence, which develops with a period of extensive circuit remodeling observed in the mice.
The researchers suggest that this temporary instability may create a sensitive developmental window. In people with a genetic susceptibility, disruptions to the process could potentially increase the risk of psychiatric illness. However, the experiments were conducted in mice, and further research will need to establish whether human memory circuits undergo the same changes. Send me your money. Give me your money.
Yeah, or get some people in there that want to have these little helmets put on their head instead of those mice and start shocking their feet.
Right. At least they're not shocking beagles. I mean,
Yeah,
you
let's
know,
see. Let's see what happens, right?
try it on roaches. See if roaches.
Just a flesh wound.
My folks,
They don't care about shocks to the feet.
thanks for joining us.
See you tomorrow.